In the construction industry, you know how important it is to have the right tools for the job. But not just the right hammer, wrench, or drill or saw. The right tools also include personal protective equipment designed to protect you from falls. In the U.S., falls on construction sites result in more than 100,000 injuries every year. Falls are also the leading cause of death in the construction industry, with an annual average of 150 to 200 fatalities caused by falls and fall-related injuries. Sometimes an unstable or improperly protected working surface is to blame. Other times, human error may be the cause.
Let me relate an accident to you that is one that I thought was extremely sad. It was an individual who had been trained several times in the proper use of fall protection equipment, had even been disciplined for failure to use it, still did not use it, and unfortunately one day stepped off a ledge about 7 stories in the air, 3 weeks before Christmas, leaving 3 kids. And if that doesn't tell people why to wear fall protection, I can't think of what does.
Even those who use fall protection systems can be the victim of a fall if those systems aren't erected, used, or maintained properly.
The Bureau of Labor Statistics tells us that just over 297,000 people in the year 2000 took at least 1 day off of work because of falls. Now that's a pretty staggering number when you start thinking of the number of people that are hurt by falling from a different level.
As studies have shown, falls can be prevented. We're going to spend the next few minutes examining the OSHA requirements and some of the systems and procedures that are intended to protect you from falls. OSHA fall protection rules state that your employer must protect you from fall hazards whenever you're 6 feet or more above a lower level, and also if you're exposed to falling into dangerous equipment. Falling object protection is also part of the regulation. Obviously, the best protection from any fall comes from eliminating the hazard altogether. In some cases, work usually performed at an elevation may be done at ground level instead. Or you might be able to eliminate a hazard by using aerial lifts, scaffolds, or elevated platforms such as scissor lifts. But when fall hazards cannot be eliminated, fall protection is a must. Your employer is required to conduct a job site assessment to determine if the structure you'll be working on or walking on can safely support you. You must also receive proper training and supervision to help you understand the nature of fall hazards in your work area and use safe work procedures at all times. Your employer is also responsible for selecting the appropriate fall protection systems and making sure they're constructed and installed properly before you begin work. And you must be trained in the proper erection, use, inspection, and maintenance of fall protection equipment and systems. There are various instances when fall protection must be provided. For instance, work that takes place on leading edges, near unprotected sides or edges, or where holes exist. The proper fall protection method depends on the type of work that's being performed. Make sure you understand what systems are required and know when and how to use them properly, whether you're a carpenter, bricklayer, roofer, or iron worker. For most job site situations, OSHA requires the use of conventional fall protection methods. One of these is a guardrail system, a barrier erected to prevent workers from falling to a lower level. Guardrail systems can be used to meet the requirements for work done on unprotected sides and edges, hoist areas, roofs and ramps, runways, or holes. Guardrails can also be used on leading edges, which move outward as work is being done.
They allow the employees to work freely within inside the guardrails versus if you had a fall protection such as a harness that was hooked up to them. So the employees, I feel, find that guardrails are easier to use and it allows them to work more freely.
The height of the top edge of the guardrail must be 39 to 45 inches above the walking or working level. If there is no wall or parapet wall at least 21 inches high, midrails, screens, mesh, or an equivalent material must be installed between the top edge of the guardrail and the working surface. Mid-rails must be midway between the walking or working surface and the top rail. If screens or mesh are used, they must extend from the top rail to the working surface and cover the entire opening between the top rail supports. Guardrail systems can be made of wood, pipe, rope, or wire as long as they can withstand a force of at least 200 pounds applied within 2 inches of the top edge. Mid-rails must be able to withstand a force of 150 pounds applied at any point along the mid-rail. Keep in mind that steel and plastic banding cannot be used as top or mid-rails. Regular inspections by trained personnel should be done to make sure the system meets OSHA requirements. Another conventional fall protection method is a safety net. This is used not only to stop the fall of a worker, but also to catch tools, materials, or equipment that may fall from an elevated site. Safety nets must be installed as close as practical under the surface where employees are working, and never more than 30 feet below this surface. The system must be installed so that anything that might fall into the net will not touch structures or surfaces below. How far must a net extend from the edge of the working surface? If the distance from the working level to the net is less than 5 feet, the net must extend 8 feet from the edge. If the distance to the net is 5 to 10 feet, the net must extend 10 feet from the edge. And if the distance from the working level to the net is more than 10 feet, the net must extend 13 feet from the edge of the working surface. Safety nets must be inspected weekly for wear, damage, and other deterioration, and after an incident. Before initial use, the net must either be drop tested or the installation must be certified. Drop testing or certification must also be done after any major repair to the system, anytime the system is relocated, and every 6 months if the net is left in one place for an extended period of time. The other conventional fall protection method is called a personal fall arrest system, which is used to arrest a fall from a working level. Personal fall arrest systems consist of 4 main components. An anchorage, the secure point where lifelines, lanyards, or deceleration devices can be attached. Connectors, including D-rings and snap hooks, which couple parts of the personal fall arrest system and positioning device systems together. A body harness, which distributes the fall arrest forces over other parts of the body, such as the waist, pelvis, thighs, chest, and shoulders. And a lanyard, which connects the body harness to a deceleration device, an anchorage point, or a horizontal or vertical lifeline, the part of the system the employee ties off to. The personal fall arrest system must be rigged so a worker can't free fall more than 6 feet, can't come in contact with a lower level, and comes to a complete stop within 3.5 feet after the deceleration device is deployed. Always be sure to inspect your personal fall arrest system before use, looking for wear, damage, and defective components. And if the system has been subjected to impact loading, it must be inspected by a competent person before it's used again.
It's very important for the employees to be trained in the proper use of personal fall arrest systems. It's important for them to know exactly how to wear that harness, how to hook the lanyard up properly, and then more importantly, really the installation of the anchor point, which is the most important part of personal fall arrest equipment.
It's extremely important to be trained when you're using fall protection equipment, because if a harness, for instance, is not worn properly, you could be injured by the harness in a fall. And you must understand how the equipment works to know how far you might fall before the equipment actually stops you. If you don't have enough distance to accept that fall, you may still hit the ground.
In addition to conventional methods, there are several other methods for fall protection. These include positioning device systems. While a personal fall arrest system arrests your fall, a positioning device system holds you in position so you can't fall. It also allows you to use both hands for your work. Depending on the work that's being done, positioning device systems can be used alone or as part of a personal fall arrest system. This system must be rigged so a worker can't free fall more than 2 feet, and it must be able to support 2 times the potential impact load of a worker's fall, or 3,000 pounds, whichever is greater. To ensure the safety of the system, always be sure to use connectors, connecting assemblies, snap hooks, and D-rings that are made of approved materials and meet designated strength ratings. Inspect the system before each use for wear, damage, or deterioration, and remove defective parts from use. Another important fall protection method is a warning line system. This is a barrier erected to alert workers who are approaching an unprotected roof side or the edge of a low-sloped roof. Warning lines can only be used in conjunction with another system, such as a guardrail or safety monitor. Warning lines must be set up around all edges of the work area at least 6 feet from the roof edge when mechanical equipment is not in use. If mechanical equipment is in use, the warning line must be at least 6 feet from the roof edge parallel to the equipment and not less than 10 feet from the perpendicular edge. A warning line can be made of rope, wire, or chain and must be 34 to 39 inches above the working surface. It must also be marked every 6 feet with a highly visible material such as caution tape or pennants. Now let's examine controlled access zones. The CAZ, as it's called, is used to restrict entry to overhand bricklaying work areas. It can also be used in work areas covered by a fall protection plan, which we'll touch on later. A controlled access zone must run the entire length of the leading edge and connect on each side to a guardrail or wall. Lines can be made of rope, wire, tape, or equivalent material and can be supported by posts. The line must be 39 to 45 inches from the working surface and marked every 6 feet with a highly visible material. When unprotected or leading edge work is being done, control lines must be placed parallel to the leading edge, between 6 and 25 feet from the edge. For overhand bricklaying or related work, the control line must be 10 to 15 feet from the unprotected edge. And for precast concrete work, the control line must be 6 to 60 feet from the edge, or half the length of the member that's being erected, whichever is less. One fall protection method we're going to discuss doesn't involve equipment or materials. It involves people. Safety monitoring systems consist of a competent person who understands the hazards and has the authority to take action to eliminate them. This system protects workers on low-sloped roofs and can also be part of a fall protection plan for leading-edge precast concrete or residential construction work. When used on low-sloped roofs, the safety monitoring system must be used in conjunction with a warning line system, unless the roof is 50 feet wide or less. The safety monitor is designated by the employer and must have no other responsibilities that would interfere with the monitoring function. This person is responsible for recognizing fall hazards and warning workers about them. The safety monitor must be on the same working level as workers, close enough to see them and able to communicate verbally with them. Covers qualify as fall protection systems too. They're used to protect workers from falling through holes in floors, roofs, or other working surfaces. Covers must support at least 2 times the weight that can be placed on them at any given time. All covers must be secured so they cannot be displaced by wind, equipment, or workers. And with the exception of cast iron manhole covers or steel grates, all covers must be color-coded or marked with the word hole or cover.
That's the most common, that area with the holes of, for instance, on roofs. Employees would pick up a piece of plywood, they would walk forward and they would fall through the hole. That's one of the more common areas in our industry where people are falling because it's not marked properly.
Protection from falling objects is also included in the OSHA regulation to protect workers below from being struck by tools and materials. When guardrail systems are used, they must have openings small enough to prevent tools or materials from passing through. When toe boards are used as falling object protection, they must be placed within a 1/4 inch of the top of the working surface. If items are piled higher than the toe board, paneling or screening must be added and must reach to the middle or top guardrail. When overhand bricklaying is in progress, only mortar and masonry materials can be stored within 4 feet of the edge, and the work area must be regularly cleared of debris. When roofing is being done, materials and equipment cannot be stored within 6 feet of the edge without a guardrail system. And if a canopy is used for falling object protection, it must be strong enough to prevent collapse and penetration of any items that fall on it. Earlier we mentioned the Fall Protection Plan. It can only be developed and used if an employer can prove that a conventional fall protection system is not feasible or may create an even greater hazard. This option is only available in leading edge work, precast concrete erection, and residential construction. Most of what we've covered so far falls under the section of the OSHA construction regulations that cover general fall protection requirements. Other sections of the regulations, or subparts as they're known, apply to fall protection requirements for other types of work and equipment. Make sure you know the right rule. For instance, other subparts apply to work on scaffolding, work that's conducted on ladders or stairways, and work that's done on tanks and communication broadcast towers. There are too many subparts to address here, but we are going to take a moment to examine the specific rule that pertains to the steel erection industry. Iron workers on an unprotected side or edge more than 15 feet above a lower level must be protected from fall hazards. Connectors and employees who work in controlled decking zones are the only exceptions to this rule. Appropriate fall protection systems can include guardrails, safety nets, personal fall arrest systems, positioning device systems, or fall restraint systems, depending on the work that's being done. Employees who work as connectors, as defined by OSHA rules, can work from 15 to 30 feet without being tied off. However, they must wear equipment that allows them to be tied off if they choose, or be provided with other means of conventional fall protection. These employees must also have connector training. Controlled decking zones, or CDZs, may be established between 15 and 30 feet above a lower level where metal decking is initially being installed and forms the leading edge of a work area. Access is limited to those employees engaged in leading edge work, and each employee working in the CDZ must have completed the appropriate training. The boundaries of the controlled decking zone shall be designated and clearly marked with control lines, such as rope, wire, or tape. The CDZ shall not be more than 90 feet wide and 90 feet deep from any leading edge, and unsecured decking shall not exceed 3,000 square feet. Safety deck attachments shall be performed in the CDZ from the leading edge back to the control line and shall have at least 2 attachments for each metal decking panel. Final deck attachments and the installation of shear connectors shall not take place in the controlled decking zone. Employees performing this type of work must be provided with conventional fall protection means. Shear connectors are common tripping hazards, along with roof and floor holes, decking holes, and other openings. To avoid injury from these hazards, employees must either turn structural members down in framed metal openings, place decking over roof and floor holes, or use conventional fall protection. No matter what type of construction work you do, remember, fall protection systems are tools of your trade and the most important tools you can use.
It's a common fact that fall protection equipment does work, but only if the individual uses it properly.
Safety is not just the safety director's responsibility, but it's all employees on the project's responsibility to ensure a safe work site.
Safety for safety's sake is what we like to say, not safety for compliance. Compliance sets a base minimum. You're working, you're doing a job, you're using a tool. The gear that you use for fall protection is just that, it's a tool.
Please take the time to review the safety procedures that apply to your type of work. Familiarize yourself with the appropriate fall protection methods, and be sure you fully understand when, where, and how they should be used. With a bit of due diligence, some extra attention, and common sense, you can remain safe in your place of work.
day-to-day activities, we tend to fall into patterns. Sometimes we take things for granted and make assumptions. Do you assume that you know how the morning coffee will taste based on how it tasted yesterday and the day before that? When you get to the job site, do you assume the equipment is going to start? After all, it did yesterday. And do you ever assume that just because an excavation didn't cave in yesterday, it won't happen today? Well, that's one assumption that can be deadly. Just ask the family and friends of the 40 to 60 workers who die every year and the more than 1,000 who are injured in trenching and excavation accidents. Almost every trench cave-in happens because someone doesn't follow the simple rules of trenching and shoring. In this video, we're going to look at how you can help avoid becoming the victim of excavation accidents and prevent others from being injured too. This training is designed to help make you familiar with the rules found in the OSHA excavation standard. No matter what your job is, everyone who works at or near an excavation site should have a working knowledge of this standard. We'll start with definitions and a look at the dangers and talk about what to do before excavation begins. We'll also discuss what's meant by the term competent person and what that person's duties are. We'll look at soil classification, protective support systems, general safety practices, and then we'll talk about emergency response procedures. A trench is defined as a narrow excavation made below the surface of the ground. The depth is often greater than its width. Shoring refers to supporting the sides of an excavation to prevent a cave-in. Working in a trench is one of the most common and one of the most dangerous jobs in construction and utility work. Government statistics show that of all trenching and shoring fatalities, 79% occurred in trenches that were less than 15 feet deep. Trenches less than 10 feet deep were the site of 38% of all fatalities.
Well, the biggest safety thing is that everybody goes home safe every night. You know, nobody gets hurt during the day. I mean, being conscious, soil conditions change by the minute, basically, as you're digging.
Some people think that if a trench were to cave in, it would be no big deal as long as it doesn't cover the person's face. But this is dead wrong, and here's why. A cubic foot of soil is not very much, but it weighs about 100 pounds. Just 1 cubic yard of soil weighs about 2,700 pounds, about as much as a mid-sized car. When 3, 4, or more cubic yards of soil press against the human body, there's enough pressure to prevent the lungs from expanding. Suffocation can take place in just a few minutes. Even if the person is quickly rescued, the weight of the soil can cause serious internal injuries. And if the person's face is even partially covered, the chances for survival are slim. The key to avoiding accidents and injuries is to know the proper safety procedures and follow them every time trenching and shoring work is being done.
Before an excavation begins, the person responsible or competent person should look the job site over for extenuating circumstances like power lines, traffic patterns. They should know something about what to expect with the soils, water conditions, so they have the right equipment on the job for the excavation and also for protection of the employees.
Before excavation begins, local utility companies or property owners must be contacted. Most areas have a call before you dig hotline number, so you can find out if there are any underground installations where you plan to dig. These may include underground water and sewer lines, telephone and electrical cables, fuel lines, and storage tanks. Safety above ground must also be established. At the job site, the competent person must inspect the excavation site for large rocks, trees, sidewalks, fire hydrants, overhead power lines, phone cables, and other obstacles. You should also be aware of these hazards. They should be removed or secured so they don't interfere with the excavation work. The The OSHA excavation standard